Hey everybody. Today we're going to cover long division of polynomials. Frequently, we have a high degree polynomial and one known factor. For example, x minus 4 is a factor of x cubed plus x squared minus 22x plus 8. And we'd like to use that fact to be able to finish factoring the polynomial. Long division is the tool that's going to let us do that. It works a lot like long division of numbers, with exponents taking on the role of place value. So let's work through the division problem I described up above and see how this works in practice. First of all, I'm going to write the divisor outside and the thing I'm dividing by inside. And I'm going to write both polynomials in order of descending degree. So starting with the highest power term and then having the exponents go down from there. And then I'm going to proceed just like I would in regular long division of numbers. I'm going to look at the highest power terms here, the highest place value places. I'm going to say, what do I need to multiply x by to get x cubed? And the answer is x squared. So I'm going to write that up top. By the way, notice that I've aligned the exponents there so the x squared terms are right above one another. I think that's a good practice to get into. Now, I'm going to multiply x squared times x minus 4, subtract, bring down the next term, and repeat the process. Now, since I'm going to be subtracting on that next line, I'm going to go ahead and change the sign as I multiply the x squared through. So instead of x cubed minus 4x squared, I'm going to write negative x cubed plus 4x squared. And now I can just add. I get 5x squared. I bring down the next term, negative 22x. Now I ask, what do I need to multiply x by to get 5x squared? The answer is 5x. Multiply and change the sign, add, and bring down the next term. What do I need to multiply x by to get negative 2x? Negative 2. Multiply, change the sign, add, and I get 0. So there's no remainder here. I've determined that x cubed plus x squared minus 22x plus 8 divided by x minus 4 is x squared plus 5x minus 2. And therefore, that cubic can be factored as x minus 4 times x squared plus 5x minus 2. Let's do a slightly harder example. This time I have a degree 4 polynomial divided by x plus 2. Again, I write it in this division notation, writing the thing I'm dividing by outside, and writing each polynomial in order of descending degree. What do I need to multiply x by to get x to the 4th? X cubed. Again, I'm aligning the exponents so that that x cubed term in my answer is right above the x cubed term in the thing I'm dividing by. Multiply and change the sign, add, and bring down the next term. I need to multiply x by 3x squared here. Multiply, change the sign, and add. This time when I add, I'm going to get 0. I'm going to bring down the negative x, and then I'll be asking, what do I need to multiply x plus 2 by to get negative x? There's not going to be any first degree term there. Notice in my answer, I'm on the first degree. I've done the third, the second, I'm on the first. So we're going to skip right over the first degree in our solution here. Basically, we're going to have to bring down not just the negative x, but also the minus 2. Because when I determine that I need to multiply x by negative 1 to get that negative x, I'm going to want to be able to cancel the constant terms, not just the first degree terms. I take that negative 1, I multiply it by x plus 2, change the sign, and add, and I've got a remainder of 0. Therefore, x to the 4th plus 5x cubed plus 6x squared minus x minus 2 over x plus 2 is x cubed plus 3x squared minus 1. Long division can also be used when dividing by higher degree polynomials, not just linear terms. Let's see an example of what I mean. Divide x to the 4th plus 2 by x squared minus 2x minus 1. So the process is going to be the same here. I'm going to say, what do I need to multiply x squared by to get x to the fourth? And the answer is x squared. Notice I've left a lot of space between the x to the fourth and the plus 2 inside of my division. I'm envisioning this as x to the fourth plus 0x to the third plus 0x squared plus 0x. Again, those exponents on the x's are taking the role of place value, and so I want to respect that place value. More directly, when I multiply the x squared by x squared minus 2x minus 1, I'm going to get x to the third terms and x squared terms that I'm going to need to subtract out. Here's what I mean. I multiply the x squared by that quadratic and change the sign, add to get 2x cubed plus x squared. Now, I'm not going to bring down the plus 2 just yet. I'm imagining bringing down 0x. Then I repeat the procedure. I ask, what do I need to multiply x squared by to get 2x to the third? And the answer is 2x. Multiply, change the sign, and add. This time I get 5x squared plus 2x. Then I bring down the 2. One more time. Now I need to multiply x squared by 5 in order to get 5x squared. Multiply, change the sign, and add. This time I'm left with 12x plus 7, not 0. Notice that what I have here is lower degree than the thing I was originally dividing by. I was dividing by a quadratic. Here I have a first degree or linear term. I can't do any more long division here. This really is a remainder. So the result of this division is x squared plus 2x plus 5 with a remainder of 12x plus 7. The most efficient way of writing that remainder is going to be 12x plus 7 divided by the original thing I was dividing by. So by x squared minus 2x minus 1. That's how you do long division with remainder.